Welcome back to this introductory lecture on proofs. In this fourth segment, we will introduce a new proof technique called a vacuous proof. And it applies to theorems of the form P implies Q. In other words, you can write a vacuous proof when the theorem is a conditional. Now remember that the conditional P implies Q is always true when its hypothesis P is false. And if that's the case, that's a situation where you can use a vacuous proof. So here is the definition of a vacuous proof of a conditional P implies Q. All you have to do is to prove that the hypothesis P of the conditional is false. And that's enough to prove the conditional. So let's consider an example of a conditional. In this case, it's the propositional function P of n, where the universe for the variable n is the set of all the integers, positive, negative, and 0. That's what we call the set Z. And this propositional function states that if n is greater than 0, then n squared is also greater than 0. Now we're not going to try to prove this propositional function, which, by the way, is not a theorem because it's not a proposition. Instead, the second theorem we're going to try to prove in this lecture is the proposition P of 0. So let's make sure we agree what P of 0 states. It says 0 is greater than 0 implies that 0 squared is greater than 0. Just to illustrate the fact that the proposition P of 0 is obtained by replacing the variable n with the integer value 0 in the propositional function P of n. So let's try and prove P of 0. Well, in this case, we observe that the theorem is a conditional, and we also notice that its hypothesis is false. In other words, 0 greater than 0 is false. We don't have to justify this. It's obvious. It's basically an axiom. And that's all it takes to conclude that the whole conditional is true. In other words, P of 0 is vacuously true because its hypothesis is false. Now, this is a very short proof, but in some cases a vacuous proof can be a bit longer because you may have to work hard to prove that P is always false. In this case, it was easy. In any case, we just completed the proof, and we indicate this with that special QED or square symbol. And this concludes this segment.